Know Your IS Code Provisions short lecture series. In this short lecture, I am going to explain clause number 7.12, that is miscellaneous items. So in this, there are some items, that is what should be the design force to be considered for design of these elements. One is foundations, and the second one is say horizontal and vertical projections coming out of the building, say something like towers, chimneys, okay, which are on the terrace of the building, and then cantilever projections, this horizontal and vertical projections, and also compound walls, the force for which they have to be designed. So these are the provisions which I'm going to explain, and what are the code provisions especially so for these design of these elements. So let me share my screen. Yeah. Okay. So miscellaneous items. So 7.12.1, that is foundations. So what code says is isolated RC footings without tie beams or unreinforced strip foundations shall not be adopted in buildings rested on soft soils in any seismic zone. So in this clause, so there are three points. First one is, it says in any seismic zone. Second one is soft soils. So that means what? If SPT value, that is corrected SPT value, N is less than 10, so that is categorized as soft soil. So this, if soft soil is there in any seismic zone, then what code says is isolated RC footings without tie beams or unreinforced strip foundation should not be adopted. So something like this one. So these are like isolated footings and there is no tie beam. So tie beam is this one. So this is fine. So in this figure, what is shown here, so there is tie beam, and if isolated footings are there and if they are connected with tie beam, that is perfectly fine. But if they are not connected with tie beam, code is putting a restriction on this. This is one thing, and also strip foundation. So strip foundation, if there is no reinforcement, so usually these are supporting the masonry structures, so load bearing structures. So if they are not having reinforcement, then these are not suggested by the code. Then the next, sorry. Yeah, the use of foundations vulnerable to significant differential settlement due to ground shaking shall be avoided in buildings located in seismic zones 3, 4, and 5. So here, what code says is differential settlement should be avoided in the building. So any type of foundation where there is a possibility of differential settlement, that is not encouraged. Then coming to the next clause, individual spread footings or pile caps shall be interconnected with ties, except when individual spread footings are directly supported on rock in buildings located in seismic zone 4 and 5. The first one was for all zones, second was for zone 3, 4, 5, and now some more restrictions in zone 4 and zone 5. What is that? Individual spread footing, if it is directly resting on rock, it is fine. Or like pile caps, they are interconnected. So if they are interconnected, it is fine. Otherwise, if they are not connected, that is not suggested by the code. Yeah. Then all ties shall be capable of the tie which is connecting this individual spread footing or pile caps. What code says is all the ties shall be capable of carrying in tension and in compression an axial force of like 1/4 of base shear coefficient, that is AH divided by 4 times the larger of the column or pile cap load, in addition to the otherwise computed forces. So we compute forces in the while doing analysis, we compute forces in this tie beam. So whatever forces are there in the tie beam, whether in compression or in tension, so we have to add this force. That what is that? AH by 4, that is 25% of AH multiplied by the larger of these two. That means whatever the load coming on that what do you call pile cap, load coming on the pile cap, multiplied by highest load coming on the pile cap multiplied by 25% of base shear coefficient. And also it is binding with this minimum 5% of the larger column of pile cap load. So that means what? AH by 4 or 5%, whichever is higher. So code is suggesting that whichever is higher. So this is in addition to whatever force is coming in that tie beam, whether it is compression or tension. In addition to that, we have to add this force. Then pile shall be designed and constructed to withstand maximum curvature imposed by earthquake ground shaking. So you can see this is pile cap and piles. So it's pile supported on pile cap. So what it says is maximum curvature imposed. So that means what? When the pile cap is displaced, so piles get bend. This is double curvature. So it should be designed for that. So designed to withstand the maximum curvature imposed on that. And there is another one, that is design of anchorage of piles into the pile cap shall consider the combined effects, including that of axial forces due to uplift and bending moment due to fixity of pile cap. So piles are fixed to pile cap. So sometimes what happens is because of the uplift and because of the bending. So these two additional forces have to be considered while the design of anchorage of piles into the pile cap. The next one is cantilever projections. So these are something like vertical projections and horizontal projections. Let's look at vertical projections first. So small sized facilities like, say, on the terrace, there is a tower, okay, maybe sometimes communication tower or whatever purpose, the tower, or water tanks, small size water tanks, parapets, smoke stack chimneys. All these are facilities which you usually find on the terrace of the buildings. And other vertical cantilever projections attached to buildings and projecting vertically above the roof, but not a part of structural system of the building. So that means they are not these are not the elements in the primary load path of the structure. So they are just kept on the building or on the terrace. So what code says is they shall be designed and checked for stability for 5 times the desired horizontal seismic coefficient AH specified in 6.4.2 for that building. So this is not for the complete building design base shear. It is the base shear which is experienced at the base of that element itself, at the base of that element. So we have to something like a floor response spectra you find out, and then find out the base shear experienced by that vertical projecting element. It can be tower, tank, or parapet, or whatever. So whatever the force which we compute, it should be designed for 5 times of that force. Why? What is the reason? These are the vertical projections which will not have enough redundancy. Redundancy won't be there. So hence we design should be such that these elements should not fail. So in the analysis of the building, weights of this projecting element should be lumped with the roof weight. Yeah. So the total weight should, in the analysis, total weight of those elements should be taken into the roof weight. But when it comes to design, they should be designed for 5 times of that element, base shear of that element at its base. So that is vertical projection. And then similar clause is there for horizontal projections. All horizontal projections of building, like cantilever structures, members, porch level or higher, are attached to the building like brackets, cornices, and balconies, which are projecting out of the building. Sorry. Shall be designed for 5 times the design vertical coefficient. So earlier clause, it is horizontal coefficient because it is vertical projection. Now this is horizontal projection. It should be designed for design vertical coefficient, so AV, for that element, and 5 times of that force. Now, what code says is this increased design forces specified in 7.12.2.1 and 2. That means vertical cantilever projections and horizontal cantilever projections are only for designing the projecting parts and their connections with the main structure. This is not for the design of main structure. So this has to be understood very clearly. So when it says base shear, it is base shear of that element, not the base shear of the building. So 7.12.2.1 and 2, that means vertical projections and horizontal projections. So they should be designed for that projecting part and their connections on. And the next one is compound wall. Now compound walls shall be designed for design horizontal quotient AH of 1.25Z, 1.25 in multiplied by that zone factor. So how this has come? So this is calculated by using I is equal to 1, that is importance factor of compound wall 1 straight away, and response reduction factor straight away like 1 taken as 1, and SA by G highest value 2.5. So if we put all these together for calculating AH is equal to Z by 2 I by R SA by G. Z by 2 I is 1, R is 1, and 2.5. So that accounts to be total 1.25 times Z. So straight away 1.25 times zone factor multiplied by the weight of that compound wall should be used for designing the lateral resistance of that compound wall. And the next one is connection between the parts. All small items and objects of the building shall be tied to the building or to each other to act as a single unit. So all these small components should be whatever projections are there, whatever items are there in the building, they should be tied up to each other or to the building to act as a single unit. So except those between the separation joints and seismic joints. So because separation joint means two independent units, two different buildings, or two different parts of the same building. So they should behave differently. The dynamic behavior may be different. So, but in the same building, all the components and objects of a building shall be tied up. Whatever furniture, all these things are, they should be tied up. Actually, these things are discussed in non-structural element code, okay, in detail. But code gives a provision here that all these parts should be tied. So these connections should be made capable of transmitting the forces induced in them, but not less than 5%. That means 0.05 times weight of the total dead and imposed load reactions. So another thing is frictional resistance shall not be relied upon in these calculations. So that means assuming that there is no friction, so 5 times the weight of that and imposed reaction, whatever is the actual load, that should be taken into consideration while designing these connections. So that is what is connection between the parts. So the purpose of this short lecture is to help students and practicing engineers to understand IS code provisions in a better manner. And following references have been used in preparation of these slides. And I sincerely acknowledge the help of my research students in preparation of these slides. So thank you.